Ad hoc public interactions between bystanders and VR users can be challenging. Consider a scenario where a bystander is trying to reach out to a VR user. They cannot visually get their attention due to the occlusion by the headset, and if the VR user chooses to wear headphones, auditory attempts to gain their attention may also be ineffective. Physical touch can be simple and direct, but also potentially uncomfortable if the bystander is unacquainted with the VR user. And while there may be interfaces for interrupting the VR user, they might require the bystander to be aware of those techniques beforehand, which may not hold true in an ad hoc public interaction scenario. So, it is important to empirically study ad hoc interruptions between bystanders and VR users to understand the diverse challenges and to develop effective solutions that can support these scenarios. One critical aspect of studying interruptions is addressing the inherent urgency typically associated with them. In a study environment, if bystanders are explicitly instructed to interrupt, it might not reflect genuine, spontaneous behavior, as they might be more relaxed and lack the natural urgency seen in real-world scenarios. So, in order to closely mimic real-world interactions, it is imperative that the interruption study creates an environment where interruptions arise from a natural sense of urgency rather than through explicit solicitation. But how do we create a natural sense of urgency for interruption? This video figure is intended to serve as a supplementary guide to the interruption study proposed in our paper. We conducted a large-scale, deception-based interruption study with 80 participants. In this study, we engineered a social scenario where participants had a natural sense of urgency to interrupt a VR user. The study was overseen by 3 experimenters with distinct roles of a host, a VR user, and a behind-the-scenes wizard. The experiment area was divided into 2 sections, a small room which was the explicit study space, and a larger shared space which served as a semi-public environment. Lastly, the study had a 2x2 between subjects design with provided interruption interface and VR application as the 2 main factors that were manipulated. The provided interruption interfaces consisted of a static interface on a desk containing a button which can be pressed to trigger the interruption, and a proactive proxy interface in the form of a telepresence robot that can proactively present the interruption controls to the bystander. Lastly, the 2 types of VR applications that were considered were an active application where the VR user played Beat Saber, and a passive application where the VR user watched a video while being seated. In order to create a natural sense of urgency for engaging with the VR user, we employed a multi-step deception scheme. The host introduced the participant to a fake study where they had to solve a series of math questions. The participants were informed that they were timed and thus had to solve the questions as quickly as they could. A couple minutes after the participants started solving these questions, the host pretended that they needed to attend to an urgent matter and had to leave for 5 minutes. However, before leaving, the host asked the participant to keep solving the questions as the timer was still running, and directed the participants' attention to the individual in the shared space and instructed them to seek assistance from this person if needed. After the host had left, the VR user donned the headset and began engaging in the VR activity. And once the VR user was in position, the wizard remotely triggered the participant's computer to lock down. Since the participants were on a clock and the host was absent, they were put in a scenario where they had to interact with the individual wearing the VR headset urgently so that they could resume solving their math questions. Post-study comments from participants confirmed that they felt a natural need to engage with the VR user and that they were not able to figure out the true purpose of the study. During study sessions with the static interface configuration, we observed that none of the 40 participants used the static interface. Instead, 24 participants physically interrupted the VR user, and 16 participants chose to not interrupt at all. Alternatively, during sessions with the proactive proxy configuration, we observed that 29 out of 40 participants used the proactive proxy to interrupt the VR user, with only 5 participants interrupting physically and 6 not interrupting at all. Our interruption study resulted in 3 key findings. Our result identified key factors that affect bystanders' comfort and willingness to engage with VR users in ad hoc interaction scenarios. Additionally, our study reveals the limitations of static interruption methods and underscores the potential of proactive, bystander-initiated interfaces in making ad hoc interactions with VR users safer and more effective. Please read our paper to learn more about our findings. And thank you for watching.